The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a mathematical tool. Title of the video, Abacus multiplication, example 7, 2 by 3 multiplied by 11, 1 by 4. Let us convert these fractions into improper fractions. In the first fraction, when you convert that into an improper fraction, that becomes the multiplication of the whole number with the denominator of the first fraction, that is 21, add it with the numerator value, that is 2, and therefore the improper fraction becomes 23 by 3. In the second fraction, you multiply the whole number 11 with the denominator of the fraction, that is 44, add it with the numerator, and therefore the improper fraction becomes 45 by 4. Now we have to treat the multiplication as 23 by 3 multiplied by 45 by 4. Let us treat the multiplication 23 and 45 separately and multiply 3 with 4 separately and follow the regular division process to get the result. Now in the first stage, let us take 23 multiplied by 45 by treating 23 as the multiplier and 45 as the multiplicand. Let us set the multiplier in the extreme left of the abacus. For setting the multiplicand in the abacus, you have to count the number of digits in the multiplier, that is 2. Add it with the number of digits in the multiplicand, that is 2. Add one place for the abacus, that becomes 5, and therefore set the multiplicand from the fifth column from the right extreme of the abacus. That is, the number 4 is set in the 10,000s column and 5 in the thousands column. In multiplication, you have to start multiplying the lowest digit of the multiplicand with the highest digit of the multiplier. So here we multiply 5 with the 2, that becomes 10. So 1 is set in the hundreds column and 0 in the tens column. Now multiply 5 with 3, that is 15. That means 1 set in the tens column and 5 in the units column. Now you can clear 5 from the abacus. Now this clears way for setting the values of the remaining multiplication. Now multiply 4 with 2, that is 8. That should be treated as 0, 8. So that means 8 is added with 1 in the hundreds column. Now multiply 3 with 4, that is 12. We can't add 1 with 9 and therefore add 1 in the thousands column. Instead of adding 1 with 9 in the hundreds column, we have added 1 in the thousands column, and therefore we have to subtract 9 in the hundreds column. Now add 2 with the already available 1 in the tens column, and the value becomes 1035. Now clear the values in the abacus, and we have to consider 1035 as the dividend, and the divisor should be treated as 3 multiplied by 4, that is 12. Now when you divide this value, that becomes the result of the multiplication of the two fractions 7 2 by 3 and 11 1 by 4. Now set the dividend in the right extreme of the abacus, that is 1 in the thousands column, 0 in the hundreds column, 3 in the tens column and 5 in the units column. Set the divisor in the left extreme of the abacus, that is 12. Now we have to apply the normal division rules. Whenever we do the division, we consider the highest digit of the dividend and the highest digit of the divisor and decide whether the quotient should be set by skipping a column to the left of the dividend or not. This is the normal procedure. However, there is an exemption to this. When you look at the first two digits of the dividend and the first two digits of the divisor, if the first two digits of the divisor are less than the first two digits of the dividend, then you need not have to skip a column in setting the quotient. Why? Because the second highest digit of the dividend becomes 0. So the rule is, whenever you get 0 as the highest second digit of the dividend, you consider the first two digits of the dividend and the first two digits of the divisor and apply the rule. Therefore, in this problem, we need not have to skip a column to the left of the dividend in setting the quotient. Now, as this is involving small digit numbers, you can straight away take 103. And how many 12s in 103? There are 8. You can set 8 as the dividend. Now multiply 12 with 8, that becomes 96. 96 should be subtracted from 103. That gives a remainder of 7. Now with the number 5 in the units column, the remainder at this stage becomes 75. Now you can consider the highest digit of the dividend, which is 7. The highest digit of the divisor, which is 1, which is less than 7. So in setting the quotient, you can always skip a column to the left of the dividend. Now you ask, how many 12s in 75? There are 6. So skip a column and set the number 6 in the quotient part, that is to the right of the already set quotient 8. Now subtract 72 from the 75. So that is clear 7 in the tens column and 2 in the units column. You cannot do that, and therefore subtract 5 in the upper abacus, and in order to compensate that, add 3 in the lower abacus. Therefore, the result is 86 3 by 12. Using the cancellation between 3 and 12, because 3 and 12 have common divisors in the form of 3, we get the result as 86 1 by 4. We can look at the results part. We have 86 followed by 2 empty columns and 3 in the units column. Now look at the divisor. It has 2 columns. That means the last 2 columns are meant for the divisor. The column which is to the left of the last 2 columns is separating the quotient and the remainder. So therefore the result here is 86 3 by 12, which is simplified as 86 1 by 4.